Everybody, could you see my screen?
Yes.
Okay,
Yes, we
like it is written some problems here. Okay. So the first of all, so you know that today is the deadline for submission of homework 2, and then on Monday, like hopefully we will return you the both sets of homework 1 and homework 2, and also in the class I will be discussing the solutions for both sets of homework on Monday. So therefore today everybody please try your best to solve all the problems in homework 2, and then you all submit by the specified deadline, I think 11:30 p.m. tonight, and then you just wait until Monday. I will be discussing the solution. So then everything will be fine. Okay, and then from now on, everybody please look carefully these numerical problems related to power factor. So everybody see the problem, a single phase series connected load draws a current IT equal to 4 cosine of, then in parenthesis 100 phi t plus 10 degree ampere, when the applied voltage is Vt 120 cosine of 100 pi t minus 20 degree volt. Then find out the apparent power and the power factor of the load, and that determine the element values that form the series connected load. So as you can see, it's clearly a series circuit, series connected load, but it does not say whether it is resistance, capacitance or inductance. You see, it is not mentioned. That's why the last part of the question determine the element values. Element values mean you have to tell after solving the problem whether it was resistance or combination of resistance capacitance or all three components. That is the meaning of element values. And before that, you have to find out apparent power and the power factor. So here you see I have just written down the answer, but then I am showing you the solution, and let's discuss, then you will understand. So let me make it bigger. Okay. So the first of all, everybody see what I have done. I have just expressed those two current and voltage quantity into phasor form, magnitude and then their phase angle, magnitude and phase angle. I mean, just look this expression. IT was 4, this one. So this means 4 at an angle 10 degree. Similarly, for VT, it will be 120 at an angle of minus 20. That is the very first thing that I did. After that, the question was find out apparent power. Yes. So therefore, you see in the last class we looked, apparent power is as VRMS multiplied by RMS. That was the definition. So this means, just I'm taking you, everybody remember the last class we were discussing this slide at the last, and look the very last one. Apparent power S was the magnitude of bold-faced S, and that bold-faced S was that actually complex power. Everybody see, complex power definition was VRMS multiplied by RMS conjugate. VRMS multiplied by RMS conjugate. And that's why in rectangular form it was P plus JQ. That was the bold S. That was the complex power. But the magnitude of this one, if you take just the magnitude part, that is the apparent power. Or in other words, in this power triangle, this hypotenuse, which was S root over P square plus Q square, that amount was the apparent power. This means just simply you need to, for example, in P and Q equation, phi V RMS I RMS cosine theta, Q is V RMS I RMS sin theta. The first part, V RMS I RMS, the multiplication of these two is the apparent power. So that's why, see the solution. What I am doing, apparent power is VRMS multiplied by IRMS, which is the, now here you see, I don't need to take into account the angle when I will be multiplying, because that is the thing. It is just the magnitude part, not including the angle. If you include the angle together with it, then that will be the complex power. Just keep in mind. So that's why apparent power simply its RMS value and then this one. But everybody see, these quantities 4 and 120, these were originally the magnitude or the amplitude. Look, in the current expression, 4 was the amplitude or the peak. Similarly, for voltage, 120 was the peak or amplitude. 120 is not the RMS value. Similarly, this 4 is not the RMS current. So that's why, but in my definition, I need the RMS. So what I am doing, the magnitude part, this 4 over root 2, 120 over root 2. And why I am doing that one? I am dividing that one. You see, we discussed this thing. Everybody see, we concluded V effective or VRMS, Vm over root 2. In case of the current, I effective, Im over root 2. You see, last class we were discussing. So this means you have to divide by root 2, their peak or the magnitude. So that's why that magnitude part is divided by root 2. And then I got 240. And then the unit is, look the unit, volt ampere. Unit is volt ampere. Now, this is the difference between the DC circuit. In case of the DC circuit, you multiplied voltage and current, but simply you wrote watt, right? If you remember DC circuit, you simply wrote watt. But from now on, in AC circuit, if you multiply voltage and current, you have to tell that is volt ampere. Accordingly, if the magnitude is result is very big, you can express kilovolt ampere or megavolt ampere, etc. So everybody, could you follow this calculation?
Yes.
Yeah, because this is the very first time you are doing this type of problem. That's why I am taking time. And everybody, please be relaxed and then look carefully, then you will be fine. Okay, so the second question was, first part is done. The second question was power factor of the load. Find out what is the power factor. So then you know that power factor was, you see, that was our definition. Cosine theta. This cosine theta, this magnitude is called the power factor. And then what is that theta? Theta is actually the angle difference between voltage and current. In fact, theta V minus theta I, whatever the amount is, and if you take its cosine, that will be your power factor. So that's why what I am writing, you see, power factor of the load, cosine of, as I said, angle difference between voltage and current. What is my voltage angle? Minus 20. Everybody say minus 20. And then minus this current angle. So therefore voltage angle minus current angle. So what I got? And then cosine of that. So then cosine of minus 30. So you all know cosine minus theta is plus cos theta. This value is 0.866. And then here I have written one term, leading. So you know the concept of leading, lagging. So we discussed, but how I wrote that on, I am coming that point soon. Hold on here. And then there is other way of finding the power factor. So what is the other way? Everybody see, here I am finding the Z, capital G, impedance, voltage over current. So now that was my voltage vector in polar form 120 over that was the current value. So then I divided. So I got here, you see, this 10 is going upward according to Phasor algebra. So I got 30 angle minus 30 degree. Therefore, everybody say that G has the angle minus 30 degree. But then here also, when I subtract this angle from this angle by this, then also I got the minus 30. Therefore, you see, two way you can calculate the power factor. One is if you see that you have the voltage and current expression and their angle available, just subtract in that way and then take the cosine. In other words, you may calculate the G and then the angle of G, that will be the same thing. And then you can take the cosine. So Other reason of that power factor. For example, here I showed the definition of power factor in terms of real power, reactive power, and apparent power. But there is other way of expressing this thing. So therefore, let me for a minute take you to that whiteboard. Hold on. So everybody see two things. And then also let me write down another one. Okay, so this one is theta. This is R. This is reactance X. And this is the magnitude of impedance root over that R squared plus X squared. Sorry, this is one thing. And then the thing that we are discussing in last class, this is P, this is Q, and then this is S. Okay, so we are discussing that power factor. So which is that cosine of theta. So therefore, we discuss this on our, therefore from this triangle, cos theta is P over S. Okay, so and then from this triangle, everybody say cos theta is R over G. Yes, look this one. And then in this case, see the similarity that, the complex vector that bold S is P plus JQ. And in this case, you see there's G impedance in vector format is, sorry, R plus JX. So therefore, this is called power triangle and this is called impedance triangle. This one is all impedance triangle. And this one is that power triangle. Okay. So therefore, you see both way you can find the cos theta from this triangle, R over J. And then exactly you will be getting the same result. So this means that what I am saying, then depending on the problem, if you see or if you can calculate the G, then use this one to find out the power factor. Or in other words, we look that G, you see, in terms of theta, definitely this G means it has a magnitude, whatever the magnitude amount is, K, and then this angle theta. Therefore, power factor is just cosine of this angle. Directly you can calculate cosine of this theta. This is the power factor. Similarly, for example, here you found out the complex power, bold S, and then you got some number. For example, you got that K1 and at an angle of theta, and then take the cosine theta. That is your power factor. So therefore, both way you will be getting the same result. And then you see this relationship is coming from this one. Really, that is the meaning. So therefore, depending on problem, many times you need to use this impedance triangle to solve problem or to make an interrelationship among Rx and G. Many times you need to use this power triangle because it is interrelated, that phi, q, and afferent power. But both way you will be getting the same result. And also, as I told you, that if you have the voltage expression, for example, that Vm theta V, and then if you have the current I equal to Im theta I, its angle, and then if you just subtract this angle from this angle, this means theta V minus theta I. And then if you take its cosine, In all cases, in this case, in this case, and in this case, all cases, you will be getting the same result. So therefore, it depends on the situation. If you have the voltage current expression available together with the angle, just subtract voltage angle minus current angle and take its cosine. That is the power factor. Or if you have available this impedance triangle, then use this one. Or just look what is the angle of with the G. Or if this system is available, then calculate P over S, or you look the complex power, what is its angle? Cosine of that one. So these all three ways you can express your power factor. So everybody, these are very, very important. It will really help you solve many, many problems. Everybody, please keep in mind. Are you getting me, everybody? Could you follow me?
Yeah.
Okay.
Yeah.
Great. Okay, therefore, let me go back there. Okay, so I think we are doing this one. That's why now everybody look. At first, when I calculated the power factor of the load, I just subtracted this angle and then minus this angle, then cosine of theta. And then next time I calculated G V over pi, I just look what is the angle of G. Just now I showed you that impedance triangle. Therefore, just take the cosine of minus 30. Then still you will be getting 0.866. Okay, now the last part of the question was that determine the element values that form the series connected law. I want to find out whether this series circuit had R, L, or C, or whatever the combination. So now what is the way? Everybody look, once you get the impedance, then this is in polar form, convert into rectangular form. So therefore, if you convert this polar into rectangular, I got 25.98 minus J this one. So therefore, what is this one? Everybody, please tell me, what is this number in the G?
The resistor.
Exactly, register, because this is real part. Excellent. And then this one, because there is minus sign. So what is your guess? Is it inductor or capacitor? Keep in mind. Keep in mind, there is minus sign. So therefore, what I am saying, then once again, everybody, capacitor, exactly. It will be capacitor. Why capacitor? Once again, let me delete a little bit. So everybody remember, the G is R plus, sorry, JXL minus JXA. Right? So when we have a series circuit that has R, L, and C, this is the G format. So therefore, if you see there is minus sign, then definitely that is for the capacitor. If you see that there is the plus, definitely that is for the inductor. And then the real part is the resistance. I think now everybody, you remembered. Hopefully you are using this equation in problem solving as well. So the minus sign indicates that is the capacitive. And then the plus sign, that is the inductive. That is the meaning. So that's why in the impedance, just by looking this minus sign, you can say this is JXC value, JXC. I don't know still that what is the exact amount of capacitance in farad or microfarad, but at least that because it is minus J, so 15 is the XC value. That's why everybody see I am writing the element values are resistor of 25.98 and capacitor of 212.2 microfarad. Now how I got that up? Everybody see XC, this amount is my XC, and what is XC? 1 over omega C. And then what is omega? Omega is 100 pi. Where you will get that on? Here. You see the expression IT 100 pi t. This is omega t. Same thing for voltage, it was equal. omega t. This means omega value is 100 multiplied by pi. So that's why to calculate say 1 over 15 omega from this one. And then I'm plugging omega value 105. So finally I calculated 212.2 microfarad. So that's why that is my capacitor value. This means that this circuit had two components, resistance and capacitor. That was the meaning of that. So everybody is fine. Do you have any question? Do you have any confusion or anything anywhere?
No, but I just want to make sure every time we're dealing with a capacitor in, let's say, XC, it's always going to be negative J every single time, and it's always going to be a positive J for an induction.
Yes, exactly. Yeah. Therefore, for example, if it would be like plus 30 here, just it depends on the problem. For example, if it would be G plus 30, then definitely in rectangular form, you would get plus sign here, right? Then if it is plus sign, definitely that will be inductor. I would say inductor. I mean, we need to calculate. In that case, it would be like XL equal to omega L 15, and then we would find out the value of L. If it would be plus sign, then always you have to assume that that is the inductive effect. If it is minus sign, definitely that is the capacitive effect. I mean, capacitor. There is always. Okay, so I think let's move forward. The other problem, then you will be understanding much more. Okay, then moving forward, everybody read the second problem. The voltage across a single phase load is VT 60 cosine of this volt, and current through the element in the direction of the voltage drop is IT this ampere. Then find out complex and apparent powers, the real power, reactive power, and the power factor and load impedance. All questions, many questions. Complex power, apparent power, real power, reactive power, power factor, load impedance. Everything is being asked in this problem. And then again, I have written down the answers. So therefore, everybody will now see the solution. Okay. So at the beginning, what I am doing, I am writing VRMS, IRMS, including the angle. And why I am doing that? Because very first question was find out the complex power, complex and apparent power. So the first one is the complex power. So now everybody see, what is my definition of complex power? Complex power, that bold-faced S is VRMS IRMS conjugate. This means you have to make conjugate of the IRMS. So that's why you need VRMS IRMS. And how we have to express? With the angle. You see, the other day I was discussing VRMS angle theta V. So at the beginning you have to write in that format because I have to make current conjugate. So that's why in the solution, what I am doing, VRMS 60 over root 2 angle, IRMS that magnitude over root 2 angle 50. So everybody say in the voltage expression it was 60 cosine of this one. But then 60 is the amplitude, 60 is not the RMS. Similarly for current, 1.5 is the magnitude, not the RMS. So I have to divide it by root 2. I have to divide this number by root 2, and then this is the angle. This is the angle for this one. So exactly I am doing this one. Look, 60 over root 2, and then its respective angle. And then IRMS, its corresponding angle. Then once I got that one, complex power, that bold-faced is VRMS, IRMS conjugate. Everybody look, IRMS conjugate. So therefore, this is VRMS part. And in the IRMS part, here it was positive 50 degree, plus 50. But because I have to make conjugate, I used minus 50. And then just simply calculation. This multiplied by this 45, and I got angle this 10 plus 50 minus 60. So you look in the complex power expression, you are getting magnitude together with the angle. Therefore, in this format, this is the complex power. And the unit is still the volt ampere. Everybody follow the unit, it is volt ampere. And then once I get the complex power, the second question was the apparent power. So therefore, apparent power is the, apparent power is the magnitude of the complex power. So this means the 45. And then now the other question is find out the real and reactive power. Real and reactive power. So therefore, if you see this one, in the complex power expression, Vrms Irms conjugate P plus JQ. This is in polar form and this is in rectangular form. Therefore, definitely the real part is the real power, and then that Q is the imaginary power or the reactive power. So that's why I had this on. This is the complex power, 40 angle minus 60. What I am doing, I am converting this polar form into rectangular form. And then I got this one, 22.5 minus J 38.97, which is P plus JQ. This means the first part, 22.5, this is the real power. And the unit is watt. And then the second part, Q value is minus 38.97. This indicates the reactive power. And the unit is VAR, VAR. Everybody, it is called reactive volt ampere. It is called reactive volt ampere. Although R is, placed at last, but if you pronounce this one, that you will be telling in that way, reactive volt ampere. Volt ampere reactive, it is not. Reactive volt ampere, just keep in mind the full abbreviation. So simply you can say from today, the unit of Q, var. So therefore, depending on the big number, kilovar, megavar, it will be like that. Now, the minus sign here, you say, because there is minus sign, that minus sign indicate this is the capacitive reactive power. Capacitive reactive power. If you get the plus sign here, that will indicate that is the inductive reactive power. So I'm coming that point, the zone and some significance of the real power and reactive power. So if keep in mind that real power is related to the resistance. Real power is related to the resistance, and reactive power is related to the inductor and capacitor. Because there is inductor and capacitor, and they are making the system complex. In the impedance equation, impedance R plus J XL minus JXC, or in the in the complex power P plus JQ. Therefore, this phase coming from the resistance, but this part plus JQ, that is coming from the imaginary component, which are the L and C. So that's why if you get the minus sign, that is the indication of capacitor. And then also, soon you will be understanding that that I am correct. Why I am saying that this is capacitor, this is not the inductor. Okay, the hold on here. And then the other question was power factor and the load impedance. There are two more questions. So therefore, to calculate the load impedance, before coming the power factor, first of all, everybody see load impedance, the Z, V over I, definitely. So what was my V? So from the expression V is 60 at an angle of minus 10, and current is 1.5 angle 50. So therefore, that load impedance is V over I simply. And then I am doing, and can you see, I am getting minus 60 degree. G equal to 40 minus 60. Actually, this minus sign indicate that this is the capacitive. You see, in the previous problem that I noticed, because there was minus 30 degree, so accordingly I got in the rectangular for minus sign, and that is the indication of the capacitor. Again, like right now here, my impedance angle, I got the minus 60. This means if you convert into rectangular form, definitely you will be getting some number minus J something, which indicates a capacitive impedance. Accordingly, this statement verifies the fact or proves the fact that this is correct, because in the complex power, I got minus sign here and P plus JQ. So this means because Q is negative here, and I already told you negative sign means capacitive. So, and then that is proved here. So therefore, how to calculate the power factor angle? How to calculate power factor? Just cosine of this angle, minus 60, 0.5. And then, so, I mean, I am going the backward. I'm just trying to make you understand that because I got minus 60, so it should be cos minus 60. But already, you know, in the voltage and current expression, we have minus 10 and plus 50. So minus 10, minus 50. Voltage angle minus current angle. That is also the minus 60. And then you see what I am writing here? Leading. I am writing leading. Why I am writing the leading? Because I know that this is the capacitor. From here also I know that this is the capacitive element. In case of the capacitive element, you know that current leads the voltage by 90 degree. That's why accordingly I have to write leading or lagging. If I would be getting the plus here, then it would be inductive. Then in case of inductance, current lags voltage by 90 degree. So I would write lagging here. Therefore, everybody keep in mind, if you see that this is capacitor, always and always that will be the leading. If it is inductor, always and always that will be the lagging. If it is pure resistance, then it is neither lagging nor leading. There is no phase difference. I mean, phase angle is 0. So in that case, you can say power factor is 1. Power factor is 1. In case of the pure resistance, power factor is 1. Everybody, could you follow me in this problem? Does anybody have any question?
Not yet.
Okay, great. Yeah. Therefore, once again, you know, after the class, you look this on like the class note or the video, then again, you all will be understanding. Okay, now the one very important problem. This is pretty interesting and then definitely quite new problem. A 25 kilowatt, 11 kV, 60 hertz industrial load with a power factor of 0.5 is being provided by a single phase power source. You are powering a load, and that load has the power capacity 25 kilowatt. Its voltage 11 kV, and then 60 hertz system, and then power factor of 0.5. And then what I am asking, is it possible to increase the load power factor to 0.9? I mean, power factor is fairly low, 0.5. I want to increase the power factor. Therefore, if so, is it by using an inductor or a capacitor? Also calculate the inductance or capacitance value are required to make the load to the desired power factor. So everybody first try to understand the meaning of the question. The power factor value is 0.5. But I am saying that, okay, is it possible to increase to the 0.9? So therefore that thing right now I will be discussing that how you can increase the power factor. And if yes, if you say yes, it is possible to increase, how you will do that? Is it by increasing inductance, adding an inductance or the capacitance? And if you choose inductor, then what is its value? If you choose capacitor, what is its value? So therefore, what does that mean? What is the, and then you say, I have written down the answer. Yes, it is possible to increase the load power factor by using a capacitor. And then this is the capacitance value. So therefore, before coming to that, what is the context? What is the significance of this question? Therefore, everybody, let's go to that whiteboard. Then you will be getting fun. So let me just keep this triangle. I think that will be fine to understand. Okay, so everybody say, then once again, what is my definition from this triangle? That power factor is cosine of theta. That is my definition. And what is that cosine of theta? Phi over S. And what is my P? P is the real power, which is expressed in watt, and Q is the reactive power, which is expressed in var, that we discussed in the previous problem, and S is the apparent power. Now, everybody say, so what can be the maximum value of this power factor? What should be the maximum value? Everybody say, this is cosine theta, and then this is P over R. So what is your expectation? What can be the maximum value of cosine theta? What is its maximum value?
1.
1, exactly, correct. So therefore, maximum value could be 1. So therefore, because maximum value could be 1, and then you say that depending on the value, it could be the 0. So this means that you can say the power factor range between 0 and 1. So therefore, when you will be getting the value cos theta value 1, when theta is 0 degree, right? When this theta will be 0 degree, only then you will be getting cos theta 1, because you see P over S. This means P and S should be the same. And when you will be getting that one, you will be getting that one only if this, like this hypotenuse fully superimpose on this one. This means that, everybody notice, this is my amount of Q, this amount, whatever it is. So then what is your goal? If you can reduce this magnitude, everybody look. For example, I reduce some amount, and then again I reduce some amount, and I'm going downward, and again I am reducing, and finally this hypotenuse fully superimpose on this. Only then my theta will be 0 degree, right? Only then my theta will be 0 degree. So therefore, because I want to get cos theta 1, and that is the maximum value of the power factor, how I can get that? Only if I can make theta equal to 0 degree. And what is the way to do that? If you can fully make, you drag this line and fully superimpose on this line. So meaning that if you can make Q value is 0, only then then phi and S value will be equal. You look this one, S equal to root over phi square plus Q square. If you can make Q 0, then it will be S equal to phi. So that is the meaning. So now that is the question. How you will make Q 0? Like I just told you that, okay, you go down, and then ultimately this S will be superimposed on this line, phi line, that will be. And what is the way to do that? The way to do that, you have to add a capacitor. Therefore, now everybody say, for example, and then now you will get fun, and you will understand the meaning of the Q. Same thing, if you think from this triangle, everybody look. This is your J, and then this is this one. This is called power triangle. So therefore, everybody say, like a while ago I defined this one. This one also, the power factor cosine of theta is R over J. So therefore, the same thing, this is power factor. when you will get the power factor value 1? If you can make x 0. Look this one. The way I said that, okay, you reduce q, make the q 0, then your theta will be 0. Similarly, you reduce x, in that way, gradually you decrease. If you can make x value 0, you look this one, if you can make x value 0, then your g will be r. So r over g, this means r over r, that will be 1. So meaning that, and what is that x? X is the reactant. You have to make that x value is 0. So how to make x value 0? Now think about, everybody look, think this one. For example, in a circuit you have that R and you had the L. So therefore this is R and then this was L. So then how to write the impedance? So therefore everybody see G is R plus JXL. R plus JXL according to this one. Therefore, that is the representation of this one. This is R, then this is X, 90 degree plus JXL, and this is the magnitude. Now, when you have this thing, then definitely there is X value. Now, what is the problem? The problem is that if you have X value, enough X value, and in this diagram, if you have enough Q value, then you are not able to get the cos theta 1. So everybody look. If you have the enough Q value, then what will be your cos theta value? Cos theta value will be low. It depends on this angle. You know how much is this one. So I mean, it will be fairly low, maybe 0.2 or 0.5. I don't know. It will be fairly low. Similarly, if you have enough very big value of x, similarly in this case also, it will be low. A low value means maybe 0.1 or the 0.2. But it is better, it is expected to get the cosine theta value is 1. That is the expectation. And why that is my expectation? Everybody, if you remember, our P equation, the real power equation was Vrms, Irms, cosine of theta. And then our reactive power equation was, everybody look, Vrms, I am not writing the word RMS, assume that those are RMS, sine of theta. So especially, you know that this one, phi equal to vi cos theta, that is the real power or the active power. That is in watt. And this is in var. So look this one, you have the cosine theta multiplied with this one. Vi multiplied by cosine theta. And that cosine theta is the power factor. Whatever this one or this one. So you have to, you look, when you will be getting the highest value of P in what? Only when cosine theta will be 1. Everybody, do you understand what I'm saying?
Yes.
Yeah, because you see, look the equation, because in AC P equal to vi cos theta, if your cos theta value is 0, then your power is 0. If it is 0.1, then like 10 times reduce. And then if you go upward, like 0.2, then 0.3, in that way, if you go much more upward and maximum value is 1, only then your P will be Vi. That will be your highest power in the circuit. That is the reason that you have to try as much as possible to make the power factor 1. In reality, it is not possible. In real practice, you can never ever make 1. But you, as an engineer, your goal should be to make the power factor nearby 1, or if possible, fully 1. Because at that time, according to this equation, I will be getting the highest power. That is the importance. But then how to achieve cos theta 1, power factor 1? From this triangle, if you can make fully Q value 0, according to this impedance triangle, if you can make fully this X value 0, only then you can achieve cos theta 1 in order to get the highest power. That is my point. How to reduce Q value 0, how can I make it 0, and how can I make X 0? That's why I am discussing this point. Now everybody come back there. For example, you have R and L, Accordingly, I constructed this triangle R and X. Now, if it is the situation that I explained, that my power value is getting low because cos theta will have, I don't know, it depends on this value and this value, maybe 0.2, 0.5, it will be significantly low amount of power. What can be done? Now everybody see, I can connect a capacitor. I can connect a capacitor. If I connect a capacitor in the circuit, then what will happen? In the impedance term, this is R plus JXL minus JXC. I am able to get this term and its effect is minus. Now everybody see what is the benefit of that? This means now I am getting this R plus then J, you see, XL minus XA. Now everybody say, look this term. If you can make XA such a way so that it cancel XL, this means that if you can make XL equal to XC, look this one, then this part will be 0. Then you are getting G equal to R. And then if you make G equal to R, this means that you don't have anything here. Only then the power factor value will be 1. Do you understand what I am saying? Everybody, could you follow me? What I am telling, that if you have G and L in a circuit, then because it has plus JXL, so accordingly, if you see this triangle, you have some value J because it is plus J. And then you are not able to make the cosine theta value close by 1. I mean, not on, even you cannot go nearby. All you can do, you have to, by force, you have to insert a capacitor in the circuit. Then what is the benefit? Because according to impedance, you know that capacitor, it will be minus JXA. And then if you can make equal value, I mean, if you can vanish this term and this term, you have to choose the capacitor value such a way that will make this condition XL equal to XA. Then in your circuit, you have only G equal to R. Only then you can make cos theta value 1. So this means that one way of improving the power factor improvement means when the power factor was very low, from 0.1, 0.2, I am gradually going upward, and then the maximum value is on. Only then the power will be maximum and my power factor value will be 1. So that's why in a circuit, capacitive have positive impact. Keep in mind, capacitor has positive impact in any circuit. It can cancel the negative or adverse impact of inductance. And actually this inductance is responsible in providing this reactance or in providing the Q. So therefore, reducing Q means cancelling the effect of the L. Therefore, in real sense, this Q reactive power comes from the inductor. Therefore, capacitor works its anti in opposite way. Because it has the minus sign originally in the impedance, accordingly it cancels, it compensates the negative impact of L because L provides the Q in the system. So you have to make it 0. And then you see this Q does not have any meaning in the system. Your P is useful power. P is your useful power because this is in watt. And Q unit is bar. It does not do anything for you. It will not help you. What it will do, it will just causing heating in the system. It will be just as a loss. It is not useful in our real life. Only few is useful in our real life. For example, think about you have a 60 watt light or 60 watt bulb, meaning that you are using the power. But if you say I have 60 bar reactive power, that cannot do anything in your life. That is just goes as a loss in the system. But then the question is why I am dealing with Q? Because in the circuit, I have the L. You cannot avoid L. I mean, let me tell you. I mean, originally in the system, probably you remember at the very first I was telling you how to produce the power. You have coil, for example. If you have the coil and if you have a magnet, if you move the magnet or if you move this coil, then you will get the voltage here. That is the principle to develop voltage, that V equal to Vm cosine of omega t. This means that if you have a magnet and a coil, then you can produce voltage. And what is the coil? Coil is nothing but the L. I mean, a coil means that it is the inductance. And because of the inductance, you see here, when you have the inductance, then you are getting plus JXL term. That inductance will take you there, plus JXL. This means that that will give you this thing, if it is the plus JXL. And that will produce you this Q. This means that for this one, just a moment, for this line, if you know that how much current is flowing through it, for example, this is I and this is L. So therefore your Q will be I square XL, I square XL for the L. This is that amount Q. So therefore that is the thing I am telling you. This Q, when current flows through inductor, it produces reactive power, this Q, and it does not give us any benefit in real life. We cannot use this power at all. It will just cause heating in the system. Then for example, what I am saying, that you have a device at your home. For example, you have a device or whatever it is, and you are noticing that gradually it is getting heated up. For example, you are putting your hand on it and you are feeling like it has some heat, and next day again you feel it is heat, meaning that your electrical device has significant amount of Q. You don't have enough P, you don't have much P, you have enough Q, and that Q is causing the heating in the system. And does it benefit you? No, it does not benefit you, because it is just getting heated. At some point it might be burnt out. So this means that you have to guess that something wrong in my device. Maybe there is more inductive effect in the system that is giving me more Q. So, and it is not of use. So what you have to do, you have to reduce the magnitude. And if you have enough Q value, then you see your cosine theta will not be 1. It will be significantly low. You see the Q equation. Q is VI sine theta. When you have enough Q, and then because in case of inductor, the voltage and current difference is 90 degree. So sine 90, you will have good value of the Q. But you see cos 90, your phi value will be 0. So that's why Q is not beneficial at all in real practice. And that is the necessity. You have to reduce the magnitude of Q. So then how to do that? By inserting a capacitor, because capacitor can cancel the inductive effect. Therefore, see this triangle. Similarly, this is the AL effect, QL effect. I am reducing Q means I am putting capacitor in the circuit. Only then I can make the Q value 0 or the close to 0. That was the context of my question here. I mean, once again, look. Once again, everybody read the question. I mean, again, we'll be looking the solution in next class. We don't have time. With a power factor 0.5. Initially, the load power factor was 0.5. And now I am asking, is it possible to increase the load power factor to 0.9? You see, I want to increase this one. Why I want to increase? Because I want to increase my active power, VI cos theta. That's why I have to increase. And then I am saying, if so, is it by using an inductor or capacitor? I think now everybody understand It is by using a capacitor. So that's why I have written the answer. Yes, it is possible to increase the load power factor by using a capacitor. And then the next question is, okay, it is a capacitor. Calculate the inductance or capacitance value required to make the load power factor to the desired power factor. Desired power factor means this power factor, 0.9. So I think everybody understand the question, right? It is kind of like power factor improvement from one low value to much higher value. That is the meaning. And then how to do that? Like I have solved it here, with the help of that triangle. You try to understand this one. I have already uploaded the slide, but in next class, I will go over it, the solution for that one. Then you will be getting fun and you will be fully understanding like why I was inserting capacitor and how it improved the power factor and what is its significance. So you just look at home. So is everybody fine?
Yes.
Okay, therefore everybody hold on here. It is very, very important and very vital problem. I mean, when you will be facing your FE exam, that highly likely that you will be getting the same question, just the change of the number of these values, but highly likely that you will be you will being asked this question in your FE exam. This is very pretty standard question, frequently being asked in the FE exam. So, I mean, in upcoming semester, because you will be giving the FE exam, so you have to solve this problem. So therefore, let's discuss in next class. Okay, so with that, I'm stopping here.